When we breathe in air, we inhale oxygen, but when we breathe out air, we exhale carbon dioxide. Unfortunately, we're not the only ones who release carbon dioxide into the air. The burning of coal, oil, and gas, otherwise known as fossil fuels, are among the contributors. Now, the ocean acts like a giant carbon sink. It sucks in carbon dioxide out of the air and stores it. Some carbon dioxide is released from the ocean. This is the natural carbon cycle. However, since the amount of carbon dioxide in the atmosphere has gone up since people are burning lots and lots of fossil fuels, the amount of carbon dioxide in the ocean has gone up too.
So when carbon dioxide hits the water, it turns into something called carbonic acid. And since it's a combination of water, the chemical formula H2O, and carbon dioxide with the chemical formula CO2, carbonic acid's chemical formula is H2CO3. And here you can see a diagram of the carbonic acid molecule. So this here is called the pH scale, and it measures acids and bases. So acids are at the low end of the pH scale, numbers 1 through 6, and include substances like lemon juice and vinegar. And pure water is neutral with a pH of 7. And bases, also known as alkalines, are at the higher end of the scale, numbers 8 through 14, and include substances like borax, ammonia, lye, and bromine. So since there's an increasing amount of carbon dioxide in the ocean, there's an increasing amount of carbonic acid. And because of all this acid, the ocean is becoming more acidic than it has been in millions and millions of years. Which is bad because carbonic acid dissolves things such as shells. So here I have 3 jars, and I put shells inside them. So this jar here is just water with a neutral pH. Here it's half vinegar, half water, so it's somewhat acidic. This one is pure vinegar, so it's very acidic. And so the 2 ones with vinegar in them show what would happen to a shell over time and in an acidified ocean. And you can see on the card there that the shell is being completely dissolved. It's almost completely dissolved in the vinegar, and it's somewhat dissolved in the half water, half vinegar, and it's whole in the pure water. So when the shells of clams and snails and other shellfish and organisms get dissolved, the animal becomes much weaker and eventually dies.
If there's more carbonic acid in the water, it decreases the amount of calcium carbonate, which is the material used to make shells and coral. Shells and coral formed in the acidified water are weaker and have less chance of surviving. High levels of carbonic acid in the water cause corals to dissolve and die. Coral reefs provide homes for at least a quarter of all marine species. So with the disappearance of these coral reefs, many of these species face extinction. It is predicted, because of acidifying waters, and if we continue on like this, that within the next 40 years, we will lose more than half of all coral reefs in the world. So fossil fuel emissions will have to be cut down immensely if coral reefs have any chance of surviving.
We're going to do a demonstration to show what happens when carbon dioxide is put into water. We can measure the pH of the water using bromoethyl blue solution, and we've put 12 drops of it in each of these cups. It's blue at a neutral pH, so it's pretty neutral right now, and it turns yellow when acidified. So Chris and Tu are going to blow it into the cups for 30 seconds, exposing it to carbon dioxide, and we'll see what happens.
Ready?
Everybody count to 30.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30.
Okay, so as you can see, they've turned like a little less blue. They're more like a greenish color now, so they're more acidified.
The pH of the oceans is changing because we keep burning fossil fuels. And this is an increasingly huge danger to shellfish, coral reefs, and the animals that depend on them. We can change this and stop endangering these animals by depending on alternate energy, like wind energy and solar energy. Not like fossil fuels like coal and gas.